This is Math Studies Lesson 10.5, and in this lesson we're going to look at normal distributions. So a normal distribution is usually called, or sometimes called, a bell curve because the shape of it looks kind of like a bell. But normal distributions are symmetric. So exactly half the data is on the left side and half the data is on the right side. They are centered on the mean, and actually the mean, the median, and the mode are all the same value, right in the middle. Okay, so we are going to use this symbol for the mean. It's a Greek letter called mu. It looks kind of like an M or a U kind of merged together, which is why it's called mu. The distance between the mean and the first inflection point, that is 1 standard deviation. So the symbol, you can kind of see it printed there, is a Greek letter, again, sigma, and that is the standard deviation, and that is the mean. The maximum point of the distribution, if I wanted the y value for there, is 1 over the standard deviation times the square root of 2 pi. So the standard distribution is such that all of the portions of it comprise the exact same percent of the population. So this region right here has 34% of the population, and this region here has 34% of the population. And the symmetry makes it kind of easy because it's always the same thing on the left and the right side. So 13.5% in each of those regions, 2.35% in each of those regions, and 0.15% in each of those regions. So if you were to add up all the numbers to the left of this line, they would add up to 50%. And same thing with to the right of that line. So those percentages are the same for every single normally distributed data set. What changes are the values along the x-axis. So remember, the mean is always at the middle, and then we use the standard deviation to scale the axis up. 3 standard deviations gets us to the end of the curve, and then standard deviations to scale the axis down, and again 3 standard deviations gets us to the bottom of the curve. So I'm going to reuse these percentages, but I'm going to try to use this also to do example A. So example A says the chest measurements of 18-year-old male footballers are normally distributed with a mean of 95 centimeters and a standard deviation of 8 centimeters. So if the mean is 95, that means I have 95 at the center of my distribution, and I will scale my axis using the standard deviation, which is 8. So I'm going to add 8 to get to the first value on my scale. So adding 8, and then adding 8 more, and then adding 8 more. And then I'm going to do the same thing to go the opposite direction, but I'll just minus 8. So if I have 95 and I take away 8, I am at 87, then 79, then 71. So once the scale is set up, I can go ahead and answer the questions that it asks me. Find the percentage of players between 87 centimeters and 103 centimeters. So 87 centimeters falls here, and 103 centimeters falls here. So the percentage between those two marks would be 68%. 34 plus 34 gives me 68. The second question says, what's the percentage between 103 and 111? Here's 103, here's 111, and the percentage between those two marks is just 13.5%. So we can add up whatever regions it asks us to. Remember, every single curve has the exact same percentages. We just change the numbers on the scale to match the situation each time. Letter B says what's the maximum point of the distribution. So this graph doesn't have the y-axis scaled, but if it did, that question is asking me basically how tall is that distribution. So I wrote the max formula near the top of the page. The max formula is 1 over the standard deviation times the square root of 2 pi. The standard deviation in this case is 8. So if I do that formula on my calculator, I get 0.499. Probably could round that to 0.5. The final example says, find the value of k such that about 16% of the measurements are below k. So, if I want to find whatever value has 60% below, I need to start on this end and work my way that way and keep adding values until I get to 16%. So at the first region, right here, 71, I only have 0.15% of the population. As I move up the scale, I move over one more standard deviation at 79. I have 0.15 and 235. I'm at 2.5% of the population. I move up one more standard deviation at 87. If I add 0.15, 2.35, and 13.5, I'm at 16% of the population. That's the number I was looking to hit. 16% of the population is below 87. That is it for the notes. Please let me know if you have any questions, and good luck on the exercises.